Today we are going to talk about addition of binary numbers. Before I start talking about addition of binary numbers, let's add two decimal numbers, meaning in base 10, and see how the operation works, because the same thing works for binary numbers. So let's say we have two numbers, 37 and let's say 18, and we're supposed to add them together. The way we do it is that first we make sure that the numbers are aligned at the first column, which is here. Then we are going to say that 8 plus 7 is going to give us 15 in base 10. But 15 cannot be fit in one space here. So we are going to write 5 here, and the 1 goes to the previous column, which we're going to say carried over to the previous column, so you're going to write a 1 here. Now you're going to add 1 plus 3 is 4 plus 1 is 5. So we say 37 plus 18 is 55 in decimal. Now the same idea works with adding binary numbers. Let's say I am supposed to add 101 to 11. Remember, 101 in base 2 is the same as, remember those multipliers? The first one is 1, the second one is 2, the next one is 4. So since 0 in the middle does not contribute anything, so we're going to add 4 and 1 together, we get 5. Now let's look at 11 in binary. When it's translated or converted to decimal, it's going to be 1 plus 2, because there are two ones here. 1 plus 2 is 3. So the answer is going to be 5 plus 3 is going to be 8. Now let's do the same thing in binary addition. 1 plus 1, which is the first two digits, are going to give you digit 2 in decimal, but 2 cannot be fit in one space here in binary, because binary goes a maximum digit 1. So we just have to remember that number 2 in binary is really 10 in binary. Number 2 in decimal is 10 in binary. So how do you write 10 in binary? You're going to write 0 here, and then the 1 goes here. Now you have a 1 here, and you have a 1 here. So 1 plus 1 is 2, plus 0 is 2, but 2 again in binary is 10. So 0 goes here, and 1 goes here. Now you have 1, 1 here, and 1 plus 1 is going to be 2, but 2 is going to be 0, and then 1 carries over to the left again, but there is nothing here, which is 0 here, so 1 plus 0 is going to be 1. So the answer is 1,000 in binary. Let's see 1,000 in binary. What is it in decimal? Remember, this one corresponds to 2, 4, 1, 2, 4, and 8. 1, 2, and 4, they do not contribute anything because everything is 0 except 8, which has a 1. So the answer is this one is equal to 8. So the same answer. Let's do one more example. Let's say you're required to add 11011, which is in base 2, add it to 111 in base 2 again. So we are going to start adding. 1 plus 1 is going to give you 10 in binary notation. Okay, so 0 goes here and 1 goes here. Now add 111. If you add 111 in decimal, 1 plus 1 plus 1 gives you 3, but 3 in binary is really 1, 1. So this one is going to be 1 here and 1 goes here. Now 1 plus 0 plus 1 gives you 2 in decimal, which is 10 in binary. So 0 goes here, and again 1 goes here. Now 1 plus 1 again is going to be 2, which is 10, so 0 goes here, and 1 goes here. Again, 1 plus 1 is 2 in binary, which is 10 in, 2 in decimal, which is 10 in binary, so 0 goes here and 1 comes here. And since there is no digit here, 1 comes down. So the answer is this one. Let's see what exactly this number represents in decimal. Remember that the multipliers are 1, 2, 4, 8, 16, 32. The only one which contributes is 2 and 32. So 32 plus 2 gives you 34. Now we are going to look at these two numbers here. This one. The only one which is not going to contribute is 0 here, so we're going to have this one is 1 plus 2 plus 8 plus 16, which is 24, 26, and 27. Now, this one, 111, is going to be, this one contributes, so it's 1 plus 2 plus 4. So 4 plus 2 is 6 plus 1 is 7. Now 27 plus 7 is going to give you 34. So everything seems to be okay.